points out of concavity and inflection points. We're talking about concave up and concave down. That's what we're talking about. The graph of a differential function, y equals f of x, is concave up on an interval where y prime is increasing and concave down on an interval y prime is decreasing. This is building up what we've done for the past two sections. The first section, you learned that from taking the first derivative test, you can find out where the graph goes up, down, you can find the max and min points. Yeah, that's what diff stands for, differentiable. We're actually going to graph a function without a calculator. What an inflection point is, if you remember from pre-calculus, an inflection point is a point where the graph of a function has a tangent line and where the concavity changes. If we're talking about a graph, just the basic ones like this, the inflection point's right there. It's where it stops being concave up and starts being concave down. It's where it changes. We're going to let f of x equals x to the fourth minus 4x cubed plus 10. We're going to find the intervals on which the graph of f is concave up, those on which it is concave downward, and any inflection points. Then we're going to sketch the graph. First thing we need to do, the first step for all of these, is we need to find f prime and f double prime. So find the first and second derivatives. First derivative is what? 4x cubed minus 12x squared. What's the second derivative? 12x squared minus 24x. We're going to find the critical points and the inflection points. In other words, we're going to find out the zeros. So factor this. Is there anything they have in common? They both have a 4x squared. If I take out a 4x squared, I'm left with x minus 3, which means I have critical points at 0 and positive 3. Because this here equals 0, and this here equals 3. For the second derivative, what do they both have in common? 12x. If I pull out a 12x, I'm left with x minus 2. So I have zeros at 0 and positive 2. Second step. We need to find the critical points and the inflection points. I have inflection, not infection this time. We get the inflection points. Step 2. We're going to find the rise and fall. We're going to sketch the sign pattern for f double or f prime and use to describe the behavior of f. So in other words, we're going to do the first derivative test. For the chart, for the 4x squared, if I put in 0, I get 0. What happens if I pick a number less than 0? It's going to be positive. If I pick a number greater, it's going to be positive. Do not get in the habit of just putting positive negatives, which some of you do. Because this is squared, it's always going to be positive. For this one, 3 is my 0. If I pick a number less than 3, what type of number do I get? I get a negative. And if I pick one greater, I get a positive. Now I'm going to find out what the sign for 4x squared times x minus 3 is. Positive times a negative. Negative. Positive times negatives. Negative. Positive times a positive. So this one goes down, down, up. I don't know why I put plus. Should have put up. That's the rise and fall. So it goes down, then down some more, then it goes up. Now we're going to sketch the sign pattern for f double prime and use it to display the way the graph bends. This is different. Normally you would just do the first derivative test, make the sign chart, and that's it. But to tell if it's concave up, concave down, we need to do the exact same thing for the second derivative. So you're going to do this for the first derivative, you're going to do it for the second derivative. Make a sign chart. Putting in my zeros. At 12x, that's my 0. If I pick a number less than 0, what do I get for the 12x? Negative. If it's larger, it's positive. This one's, the 0 is at 2. If I pick a number less than 2, this one is going to be negative. Greater will give me positive. Negative times negative is a positive. Positive times a negative. Negative. Positive times a positive. Positive. What this tells me is this is concave up. This is concave down. And this is concave up. The way to think of this, it's going to be like this, it's going to be like this, it's going to be like this. Now if I go back, this point right here, what would we call it? Nothing. What would we call this point? A relative min. Now this one changes. It goes from concave up to concave down. This is an inflection point. This goes from concave down to concave up. This is an inflection point. Do you understand the differences? First derivative will tell me relative maxes and mins. The second derivative will tell me inflection points. Now we're going to summarize and put everything together. We're going to summarize all the info, put it together. We're going to put it from steps 1 and 2, and we're going to show the shape over each interval. I don't know why I have. This is piecing everything together. If I looked at it for the first derivative, it went down, down, up. So it goes down, down, and then it was after 3 is when it went up, right? So it's going to go down, 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 up. The second derivative. It started going, it's up, then I hit my inflection point, it's concave, up. Concave down looks like this. Then it goes down, and then it's going to go up because this is a minimum. Piecing the graph together. I made it angled like so they can connect. Okay? Because what I'm going to end up doing is we're going to graph this. There's a lot of steps to this. This is going to connect with this. This is going to connect with this, and this is going to connect with this. And it's going to be one entire graph. Each one of these points tell me something. This was an inflection point. This was an inflection point. This was a minimum point. That came from my previous two graphs. The 0 and the 2 were inflection points. The 3 meant it was a minimum value. The only one they overlapped was the 0. And 0 was nothing on the first derivative, but it's an inflection point on the second derivative. The easiest way to graph this, the first thing we have to do is find out what f of these 3 points are. So find out f of 0, f of 2, and f of 3. Those were my 3 points. So find out what f of 0, f of 2, and f of 3 is. You're just going to put those 3 points into the original function. The original one. So I'm going to put in f of 0. 0, 0, my answer is 10. F of 2. So I have 2 to the 4th minus 4 times 2 cubed plus 10. Fine. 2 to the 4th minus 4 times 2 cubed plus 10. Negative 6. Now I need to do the exact same thing for 3. And the faster way to do it, second, enter, change the 2's to a 3. Negative 17. So there's my 3 values.
Can I have your attention, please?
Okay, on your graph paper, make an XY axis, and we're going to graph each one of these points. All right, I'm going to graph all 3 of those points. My first point was 0, 10. 0, 10 is right here. This is an inflection point. The next one was 2, negative 6. So 2, negative 6. That was an inflection point. And the next one, or the last one, was 317. And this one here is a minimum point. So graph those 3 points. How does the graph start off? Looking at our table right here. What happens? It goes down. So this one starts off going down. Once it hits that inflection point, what happens? Well, it's going to change, so it's concave down. So it's going to hit my another inflection point, which is on mine, way down there. Then it's concave up. So it curls this way. And then that's the minimum, so it just curls up. My dots are really small, so it makes the graph really stretched out. Yours is probably going to look a little bit different than mine and probably a little bit neater. This is the general shape. This is the graph. If I were to graph the original function, the original function was x to the fourth, what was it, plus minus 4x cubed plus 10. Oh. Trying to get the graph so I can see it the best on the calculator. Let's see. The window, I know the y value, or the x values. I'm just going to go from negative 10 negative 10, positive 10. I'll jump by 1s. The maximum y, I'll make it 15. The minimum y, or sorry, the minimum y, I'll make it negative 20. The max, I'll make it 15. I'll jump by 1. Should look the same as your graph. The graph is concave up. Hits the inflection point at 10. Now it's concave down until it hits to negative 6. Then it just keeps going down more until it hits the minimum at negative 17, and it goes up to infinity. Questions? And they will take a while to do. You have to be careful. This problem here is your homework. You have f of x equals 4x cubed minus 6x squared minus 9x. You're going to find the intervals in which the graph of f is concave up, concave down, and any inflection points. Then sketch the graph. In other words, you're to do all the same steps. Just do the graph on the back of the graph paper I gave you.